Hi everyone, myself Raju KJ. So we go with the Dcet 2018 question paper and the question paper code is A. In this question paper, I am going to discuss with the analysis and designing of algorithm. The question start with 156. The first question is, which of the following case does not exist in complexity theory? So before going to a question, let's discuss on what is complexity theory. So the complexity theory is nothing but how fast the algorithm works based on the input. Okay, so the algorithm, it is one of the characteristics of algorithm efficiency. It depends upon the input size n. N is nothing but the number of inputs given to an algorithm. Based on this, we are going to classify into best, worst and average case efficiency. So there are three cases: best, worst and average case efficiency. The first two, worst case efficiency. So the worst case efficiency is nothing but the efficiency is equal to the size of n. N is nothing but number of input. The worst case is nothing but as in it depends upon its input size is n. So the algorithm runs longest among all possible inputs of size n. So means the algorithm will going to run longest one. Next is best case efficiency. In the case of best case efficiency, the algorithm works in which best of input size n. That means it runs fastest among all possible input of size n. If you give any input, it will run fastest. Then the next one is an average case efficiency. The average case efficiency is nothing but it will stands between the worst case and the best case. It is a possibility instance, means we cannot guess that the algorithm will runs either this much of time or this much of time. So it stands between worst case and the best case. Okay, coming to a question, which of the following case does not exist in complexity theory? So the correct answer is null case. So algorithm either should works either the best case, worst case or the average case. Among these three, algorithm stands with any one of the case, not in the case of null case. So means what? The algorithm should be having any one of the case among these best, worst and average case. Okay, the second question, 157, question number is 157. Dash is the last step in solving the problem. Okay, solving the problem, it takes in a stepwise manner. So we will discuss one by one. First is an understanding the problem. So understanding the problem is the first step in design and analysis of algorithm. The given problem is must understand the first before going to for the solution. So the second step is decide on computational means exact versus approximate solving. Next, algorithm designing technique. So depending upon the problem, we must be calculate computational means. Which are the computational means which we will need for designing of algorithm? It will take as an functional requirement and non-functional requirement. Next is exact versus approximate solving. Let's try the problem by solving either exactly or approximately. For the exact solving, just giving a small example, finding the route from one city to another city. So we must have as an one exact solution from one city to another city. The approximate solution example is square root of -1. So we cannot possible to solve the problem exactly. So we go with the approximate solution. Next is algorithm designing technique. So there are a lot of algorithm designing techniques available. So such as divide and conquer technique, brute force method, decrease and conquer technique. These are all algorithm designing techniques. Based on the which one is suitable for the given problem, we must decide. Next is design an algorithm. So we go for designing of algorithm either the using a flowchart method or as an by using a pseudocode or by using step-by-step procedure by writing as in the natural language method. So it is a designing an algorithm. Next, prove the correctness. So correctness is nothing but as an how the algorithm yields the correct result for any given legitimate input. So if in the case of anything wrong, we go with the decide on computational means, exact versus approximate solution, or algorithm designing technique and design again the algorithm. Next step is analyze the algorithm. So analyze the algorithm is nothing but how much algorithm yields the correct result in a given amount of time, and also how much the extra space it consumes to for a given algorithm for a given correct result. Next step is last step is code the algorithm. Code the algorithm is nothing but for any designed algorithm, after its proving correctness and analyzing the algorithm, we must go for as in coding. So either go for C, C++ or Java, any of the coding language used to yields the algorithm into an final productivity. So these are the steps carried out in the algorithm designing technique. So come to the question, dash is the last step in solving the problem. So solving the problem, first is an understanding the problem, yes correct, identify the problem, this is also as an not in the case of algorithm, then evolving the solution, so this is also not last step in the problem solving. Fourth is none. So the correct answer is none, because the last step in solving the problem is code the algorithm. Okay, we go for the next question. Next question is 158. Which is the best sorting technique when the list is already sorted? So list is already sorted means, so go for as a choice. So first one is insertion sort, second bubble sort, third merge sort, fourth selection sort. So in case of array is already sorted, then the best case is insertion sort, because when we playing with an split card, when we pick all the cards which are already in sorted means we are not replacing the any cards, so there is no any replacement of elements, so that is an insertion sort. In case of bubble sort, each element will be compared with all the elements and the selected element is replaced with each other, so the bubble sort will takes as an longest time. Then merge sort. Merge sort is a divide and conquer technique in which each array is to divide into two equal parts and merge by sorting the elements with each other. Fourth one is an selection sort. In case of selection sort, it is same as the bubble sort. Here we finding the smallest element first and place it into a final first position, so it is also takes as an longest time. So the best sorting technique when the list is already sorted is the insertion sort. First answer is right answer. We discuss one by one. The first one is an insertion sort. In case of insertion sort, for example, I taken as an array 89, 45, 68, 90, 29, 34, 17. So it is just like as an playing an split card. So I holding the card with number 89 and picking the another card as 45. So where it I want to place, either below or above the card of 89. So if it is an less than, I need to place it below the 89. If it is a greater than, I need to place it into above the 89. So the 45 is less than the 89. So I am placing it into below the 89. So what happens if the case of the second card is already sorted? Sorted means I am not going to replacing of the 89 by 45 position of 89 by the 45. So means what? 89, 45, 68, 90, 29, 34, 70. Those are all in the same order if they are in the sorted order means. So 1, 2, 3, 4, 5, 6, 7. If the cards are 1, 2, 3, 4, 5, 6, 7. If I place taken as a card number 2, I just holding it. If I play taken as a card number 3, it is in the same position as third position. If I taken as a card number 4, it is in the same position. So there is no any replacement or swapping techniques. So the insertion sort will not works on the sorted array. It will just check the elements one by one. The next option is bubble sort. Let's see how bubble sort will works. So in the case of bubble sort, it will compare the first element with its adjacent element. So if it is an out of order, just replacing the with each other. Again the second element with the third element. If it is there out of order, again replace with each other. So just keep on repeating. We just finding a largest element and placing it into its final position. This is for finding the first largest element, that is an 90. So again we go with the start with the first element 45 and compare with its adjacent element up to the n-1 times. So means what? We are finding the second largest element and placing it into final position. What happens in the case of it is a sorted? So 1, 2, 3, 4, 5, 6, 7. So 1 is compared with the 2. So there is no out of order. 2 is compared with the 3. 3 is compared with the 4. 4 is compared with the 5. 5 is compared with the 6. 6 is compared with the 7. Again we are repeating. 1 is compared with the 2 up to the n-1 times. So means what happens? Again the same steps are going to repeating with each other. So it is the worthless. So next is merge sort. In case of merge sort, dividing the array into two equal parts. So for this we are dividing the array into two equal parts, 89, 45, 68, 90. So one side and 29, 34, 17 on the another side. So it just like as an, I will just show you the how the divide and conquer technique will works. Okay, just look into the picture. So there the array is dividing into two equal parts. Again the array is dividing into two equal parts up to the size become 1. After that start merging one after the another by comparing with each other. So at the end we get the sorted array. So this whole process will repeat when you given as an the array is in sorted order also. So this is also an worthless. So go with the selection sort. Selection sort is same as an bubble sort, but in the case of selection sort we are finding a smallest element first. As in the case of bubble sort we are finding the largest element first. Here we finding the smallest element first and place it into its final position. So again we start finding the second smallest element in an array and placing it into second position. So just keep on repeating at the end of the all the loops we find it as an sorted array. Here also it is a worthless because each time we are start comparing the first element with all the element, and second element with the all the elements, third element with the all the element. So the number of comparison will be more. So this is also an worthless. So the best answer for sorted array is in the sorted array. So the best sorting technique is insertion sort. So just go for as in next question 159. Two main measures for the efficiency of an algorithm. So two main efficiency algorithms are: first one, process and memory; second, complexity and capacity; third, time and space; fourth, date and space. The best the answer for this question is time and space, because at the end of the designing technique we just go with the how much the algorithm will works on the case of time and space for any legitimate input. This is a one of the, in the case of definition itself we are telling that, so how fast the algorithm works and how much extra space it consumes. So these are the two main factors which affect the efficiency of the algorithm. So not an memory and the process. So nowadays the systems have a huge amount of memory and the lot of computational power. So we are not concerned with the process and memory. And complexity and capacity. So complexity and capacity, the process is work multi-core. Then if the algorithm is complex, then it is easily to compile and runs. There is no question about the complexity because computer can understand it. Date and space. Date is not data and space. Sorry, data and space. So data and space is not the one which is going to be affecting the efficiency. So the only thing is an time and space, because if they more complex, then it takes the more time. So the time is the one which will be decreasing the efficiency. And the space, how much extra space it consumes, because data, whatever the input data given, that will take as an input space. And what are the computational space, means when I start computing the solution, how much extra space it consumes. That is also as an one of the thing which will affect the algorithm efficiency. So the right answer is time and space, option third for the question 159. Okay, the last question, the time complexity of linear search is. So the time complexity of the linear search options are 1, big O of 1, 2, big O of log n, third, big O of n, and fourth, big O of n log n. So we will first discuss with the what is linear search. So linear search is nothing but as an finding the elements in a given array. The finding element is called as an search key. So search key is found finding one after the another element by comparing with each other. So this is called as a sequential search. So sequential search is nothing but searching a given key element in a given array one after the another, or it is also called as a consecutive elements. So at the end of the array, if it is found in the middle of the array or in the comparison, in any of the comparison, we stop the comparisons and returns the index of the array. If it is not found, we returns as an -1, that is indicated that we reach the end of the array. In the worst case of the linear search, means if it is not found, then also we just comparing all the element. So that is the worst case is n, and the best case is the element is found at the first position. What happens if it is found at the first position? So the best case is a 1. Then the average case is nothing but as an the element may be found in between 1 and n. So in between the 1 and n, it is the average case. So the come to the question, the time complexity of linear search. So big O of 1, that is an best case, and the third option is big O of n. So it is the worst case. So element may be the found at any time, anywhere. So we cannot guess. So that is an big O of n is the correct answer. The time complexity of linear search is we go of n. So we are trying to comparing all the elements in a given array to find the element. Okay, this is the end of the design and analysis of algorithm in DCET 2018 and series is A. So myself Raju. Thank you one and all.